In today's video, we will learn the change of base formula for logarithms, discuss its proof, and illustrate it with examples. Throughout, we will assume that we have positive logarithmic bases that are not equal to 1 and positive inputs into logarithmic functions. The change of base formula says that we can change log base a of x to any base b by dividing log base b of x by log base b of a. In practice, we choose the base b to be convenient. For us, convenient means we use either base 10 for the common log or base e for the natural logarithm, because these two functions are programmed into most standard calculators. For example, we can write log base 2 of 3 using common logs as log 3 over log 2, or we can write log base 2 of 3 using the natural log as ln 3 over ln 2. ln is short for natural log. We can convert the common log of e to the natural log and simplify, knowing that the natural log of e is 1. Before we look at more complicated examples, let's consider the proof of the formula. In our solution, we're going to utilize the relationship between logarithms and exponents. Let's let m denote log base a of x, let n denote log base b of x, and let p denote log base b of a. Converting these logarithms to exponential form, we have that a to the m is x, b to the n is x, and b to the p is a. We then get that a to the m is equal to b to the n, since both of these equals x. And we also have that b to the p equals a. Then substitution yields that b to the p raised to the m power, substituting b to the p for a, equals b to the n. Using laws of exponents, we have that b to the pm equals b to the n. And since we have equal bases, we know the exponents must be equal, so pm is equal to n. We can divide both sides by p, which we know is non-zero because a is not 1. And finally, substitute the original logarithmic expressions to get the desired formula. Now let's consider a few examples. First, let's go ahead and approximate log base 2 of 3. We know that x equal log base 2 of 3 provided that 2 to the x is 3. This value is definitely not an integer. We know it's between 1 and 2, since 2 to the 1 is 2 and 2 squared is 4. We will use the change of base formula and write log base 2 of 3 equal the natural log of 3 over the natural log of 2. Using a calculator, we get an approximate value of 1.58496. Definitely between 1 and 2. We can check our answer by evaluating 2 to the 1.58496 on a calculator, and we get approximately 2.999948. Five nines and a 4/8, which is pretty darn close to 3. We can get greater accuracy by using more decimal places in our original approximation. Let's consider another example just to reinforce the formula. We want to evaluate log base 5 of 100. Using the change of base formula, we can write this as the natural log of 100 divided by the natural log of 5. which is approximately 2.86135 using a calculator. Again, we can check this solution by evaluating 5 to the 2.861353 and get something that is pretty close to 100. Finally, let's use the formula to solve an equation. 3 to the x equals 7. We'll start with the given exponential equation and convert to the corresponding logarithmic equation. Now we need to simplify log base 3 of 7. So we use the change of base formula, get a calculator approximation of 1.77, and again we can check by substitution that we have an x that satisfies our original equation.